Hello again. So let's continue with chapter 2 in section 2, and we're going to talk about the graph of a function. So last time we talked about functions and how to plug in numbers and what they look like and what a function means. So now let's look at it, what it looks like in a picture form. So let's learn how we identify whether a graphic is a function or not. And let's see what kind of information we can actually obtain from or about the graph of a function. So first things first, let's look at the different ways to identify whether a graph is a function or not. So the theorem, the definition, the basics is a vertical line test. So vertical line, straight up and down. A set of points on the xy plane is the graph of a function if and only if every vertical line intersects the graph at most one point. So the biggest thing to take away from this, remember, you can only have one y per x. Since x is along the horizontal, if you take a vertical line and run it along x, it can only intersect whatever figure you're in one time. That's the whole thing with it. Okay, so let's take a quick look at a few different graphs and let's see which ones, if we can determine which ones are functions. So for A over here, okay, we have y equals x squared. So remember, we want to know for one x, there's only one y. So vertical is up and down. So every time I do a line, we need to make sure it hits that blue only one time, and that's it. Okay, this one does, so it is a function. Okay, vertical line test for B here. Again, no matter where I draw a line, it is only going to touch that blue line one time. Now, let's take a look at C and D though. So if I draw this line here, it's actually touching at more than one point. So that is not a function. Okay, and the same thing goes for D here, which is our circle. Any place. Now remember, it only has to happen one time for it to not be a function. But if I have something like this circle, every time I do a vertical line, it's touching more than once. So that is definitely not a function. So, but what other information can we actually gather by looking at some of these graphs? So the best thing that we can do to go through this so I can show you what kind of information you're going to get is to actually go through an example. So the next slide, this one has, we're going to go through these step by step. We're going to start at A, we'll do B and C, so don't get overwhelmed, okay? But here is my graph. So my f is the function whose graph is given in this picture. Do I care what the equation is? No, because I do want to be able to read the graph. So first of all, we're going to find three values at some given numbers. We're going to look at the domain and the range of it. We're going to look at the intercepts and how many times does it cross a specific line, and for what values does it equal a specific thing, or for what values is it greater than. So let's start off baby steps. Let's look at number A and let's isolate A here. So if we take out just A, so what are the values of f of 0? First of all, it's going to be baby A, this is going to be baby B, this is going to be baby C. Okay, well that's a terrible looking C. So for baby A, f of 0, so f of x equals f of 0, which means my point is at 0, right? Because 0 is x. So if I look on my graph, okay, what's the 0 here? It's this point right here, 0, 4. Okay, we can read that right off the graph. Let's look for baby B. F of x equals f of 3 pi over 2. And that's going to be 3 pi over 2. and a value. So let's look at this graph. We want to find the x where it's 3 pi over 2, which is right here. So there's my coordinate point. Okay, we're just reading it off the graph, directly off the graph. So baby C, f of x is going to be equal to f of 3 pi. Okay, so it's going to be a 3 pi and what? If I look over here on my x, 3 pi is x right there, so 3 pi minus 4. Okay, easy peasy. With this graph especially, they gave us a bunch of the points at the max and mins, so we were very easily able to read directly off the graph what those values are. So next, let's look at the domain and the range of this function. Now, if we remember, okay, the domain, x is the domain, and y is the range. Okay. Now, so my x is going from here, which is x equals 0, up to here before it stops, right? And that x equals 4 pi. Okay. So my domain is equal to all x's between 0. So my domain is everywhere between x is 0 and 4 pi. Now, let's take a closer look, though, at whether it's inclusive or exclusive, because inclusive is going to give us the underline or equal to. The exclusive is going to give us one without. So this actually has a point. It's a closed-in point, so it's inclusive. This one also has a colored-in point, and so it is, well, inclusive. So that's my domain, okay? If I want to do it in interval notation, I'm going to say square brackets, because it is inclusive, 0, 4 pi, square bracket. Okay? Now the range. So the range is going to be all y's, such that. So where my y is maxing out here, right? So that's 4. And the minimum is down here. So y equals -4. So my y is everything in between. It never goes outside of those. So I'm going to have from -4 to 4. Okay. Closed dots, which means that they're inclusive. I am equal to it. So I need to make sure that it's less than or equal to. Okay. On interval notation, because it is equal to, it's square minus 4 comma 4. Square again, equal to. Okay. So we're getting a lot of great information out of this one graph. So next thing we want to do, let's look at the intercepts. Let's take a look at the intercepts. So we're going to remember that an intercept is where it crosses or touches any of the coordinate axes. So for this one, we have this point, we have this point, this point, this point, and that point. So all we have to really do is write out those points. Pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. Okay, we've got your x-intercepts are where your y equals 0, and we have your y-intercept where x equals 0. Okay, so we can also find that off of the graph itself. So we only have a couple more things that we want to look at. And so how many times does the line y equals 2 intersect this graph. So y equals 2 is going to be a horizontal line, right, through the graph. Now, I'm going to attempt to make a straight line. Good luck to me. Yeah, okay, it's not terribly straight, but we get the idea. Okay, so how many times does it cross? 1, 2, 3, 4. So it crosses the graph 4 times. Okay, so all I really did was I drew a second graph onto my coordinate system, and I counted how many times they crossed. No big deal. Last but not least, let's look at some different equations. So for what value of x does f of x equal minus 4? So what we're saying is y equals minus 4. So we want to know where y equals minus 4. If I draw the line y equals minus 4, well, see, that's not even a straight line either because it's supposed to go through this little point. Let's see if I can do that again. We're just going to make it a really thick line. It covers up all the boo-boos. Okay, so if I draw the line y equals minus 4, I can see that it crosses here and it crosses there. Okay, so for what values of x, so where x equals pi and x equals 3 pi, because what it's asking for is the value of x where y equals minus 4. Okay. Now, the last question that we have to look at for today is what value of x is f of x greater than 0? So where is y greater than 0? So y is equal to 0 here, okay? But we want greater than 0. So it's going to be everything above that. Okay, so we've got a few different pieces. It's going to be this piece, and that piece, and that piece. So we've got 3 different pieces that is making it greater than 0. Now remember, this is not a greater than or equal to, so we're going to have some round brackets. So let's take this first, and let's do this in interval notation. So this first piece here, x is in the from 0 to pi over 2. And it's the non-inclusive bracket because we're not equal to, okay? Now I'm going to do that union notation because I'm going to do 3 separate pieces. Again, it's equal to, so we don't want to put those, so we're going to use the rounded brackets instead of the square brackets. And it's going to be 3 pi over 2, which is here, to 5 pi over 2. And again, rounded union. Okay. Last but not least, we've got this last little portion here, which goes from 7 pi over 2 to 4 pi. Now, at 4 pi, we are equal to. So let's go ahead and put the square bracket. Okay. Now, if I was going to do the inequality notation, it would be, let's see, 0 equal to, because we are up there, right? X pi over 2 union 3 pi over 2 x 5 pi over 2 union 7 pi over 2 x equal to 4 pi. Okay, so we were able to get a whole lot of information out of just reading the one graph. Okay, again, take it in baby steps, go chunk by chunk, and don't freak out on me. So, as always, if you have any questions, ask one of your professors, and I'll see you next time.